In this short video, I am going to explain you something about the individual moment of inertia along the x-axis and y-axis, that is Ixx and Iyy, often some individual figures like square, rectangles, triangles, circle, semicircle, etc. It is almost, we can call, it is a ready reckoner for you. Just to summarize the whole concept about the moment of inertia at its own center of gravity along x-axis as well as along y-axis. Now, first of all, I will first show this is a square with a this dimension is equal to this dimension AA. So we can say that if this is the moment Ixx along this axis, which is acting at the center, moment of inertia along this is equal to 1 upon 12 A cube. A cube. Similarly, along the y axis, passing through the CG, same because A and A is equal. So 1 upon 12 A cube. Whether it is the x-axis or y-axis, Ixx is equal to Iyy is equal to 1 upon 12 A into A cube. Rectangular section. If this is the width and this is the depth, and the CG lies over here at a distance of d by 2 from here and b by 2 from here, then moment of inertia along this axis, along x-axis, Ixx is equal to 1 upon 12 b d cube. 1 upon 12 b d cube. Where, when we are talking about this axis, b will be always parallel to this axis and d will be always right angle to this. Now, when I am talking about Iyy, 1 upon 12 bd cube means here in this case it is 1 upon 12 db cube. Always consider b, that is the width of a section along the axis. Now, let us have something about this similar triangle. The CG lies at a distance of h by 3 from the bottom with a base b and a total height h. Then its own center of gravity Ixx is equal to 1 upon 36 bh cube. 1 upon 36 bh cube at distance of h by 3 from here. Iyy is the same as 1 upon 36, but not bh cube, it will be hb cube. It will be hb cube. About circle. Having diameter as d, you know that Ixx is equal to Iyy, symmetrical section. So, the Ixx is equal to pi by 64 d to the power 4. Similarly, Iyy is also equal to pi by 64 d to the power 4. About semicircle, the CG lies at a distance of 4 by 3 r by pi from here, and at x-axis, when I am just trying to give the value for Ixx of a semicircle, it is pi by 128 d to the power 4. D to the power 4. That's over and all. These are all the individual figures, moment of inertia along the x-axis and y-axis is given. On the basis of this now, how we come across to calculate the value for the composite moment of inertia of a composite section, that we will discuss in our next part.